Now, today we shall be looking at a very important concept, underfitting and overfitting. And I love the way it was expressed in this textbook, which I highly recommended. And you see here, underfitting is defined as a situation when your model does not perform well on the training set. Essentially, when you have a problem at hand in which you are trying to learn an algorithm using a data set, you divide your data set into three buckets. You have the training, you have the validation, then you have the test. The test set is often just kept, and you just, after you are done with all you want to do, you just use the test set and run it on the model just once, and you report that in journals and papers in the community as your final result. So you use your training set to be able to train the model. Now, when your model does not do well on the training set, that is when the training error does not diminish, does not decrease, then that is underfitting. It means that your model is not capable of doing the job at all. So if your model is doing well, we expect that the model should be, at every iteration, at every epoch, should consistently be improving on the training error by having lower and lower error on training. Now, once we're done with training and your model does well, then we can go into the validation set. So the point now is your trained model, we use it on the validation set and see what the performance of the model is on the validation. If the performance of the model, the error of the model on the validation is equal or less to that of the error on the training, then we say that the model is doing very well. Otherwise, if the model is having a very large error on the validation, then that means the model is overfitting. Overfitting means that the model has done very well on training, but it has failed to do well on test. So what you want to achieve is you want to ensure that the gap between the training and test error is as small as possible. That is when we say that the model is actually generalizing well. That's the concept of generalization. Thank you, and see you in the next one.